Motofocus presents an in-depth exploration of the 2026 F-47 NGAD, the next-generation air dominance fighter, redefining the boundaries of aerospace engineering, stealth integration, digital warfare, sensor fusion, and autonomous combat operations. This script examines the aircraft from every technological angle, emphasizing the breakthroughs that elevate it beyond fifth-generation designs and position it as the future benchmark of aerial supremacy. Origins and strategic purpose. The 2026 F-47 NGAD emerges from a global shift in air combat philosophy, driven by the need for uncontested airspace in a world of rapidly advancing anti-air systems. Traditional fighters, even those engineered with advanced stealth, face saturation threats from hypersonic missiles, AI-enhanced radar systems, and integrated air defense networks. The NGAD program was conceived to counter these challenges by creating an adaptable, ultra-networked platform capable of real-time threat prediction, autonomous strike problem-solving, and persistent electronic penetration operations. Instead of designing an aircraft that simply outperforms existing fighters, engineers aim to create a system that rewrites the rules of aerial combat itself. Stealth evolution in multispectrum ghosting. The F-47 NGAD introduces sixth-generation stealth architecture with multi-spectrum ghosting capabilities. Unlike traditional low-observable surfaces that primarily deflect radar waves, the NGAD employs active stealth modulation. This system uses electromagnetic skin panels capable of altering signal absorption and dispersal based on radar frequency, threat angle, and atmospheric conditions. The aircraft can reshape its detectable signature dynamically, eliminating pattern recognition from enemy AI radar. Infrared suppression is enhanced through directional heat venting that channels thermal energy into vortex pockets, reducing both plume visibility and long-range IR tracking probability. In electromagnetic warfare zones, the NGAD can momentarily enter null mode, where it generates a controlled distortion bubble that mimics environmental noise, making it indistinguishable from natural sky clutter. Aerodynamics and morphing control surfaces. The airframe incorporates adaptive morphing surfaces built from memory fiber alloys. These surfaces change curvature and edge geometry based on flight demands. When performing extreme maneuvers, the wings stiffen to maintain stability during high-G engagements. At long-range cruise profiles, the surfaces smooth out to reduce drag and increase fuel economy, enabling deep-strike missions without external tanks. The aircraft's curved chine lines and blended fuselage to wing transitions eliminate turbulence pockets, producing a near-frictionless aerodynamic flow. This allows the NGAD to sustain transonic acceleration for extended periods, giving it unmatched energy retention in dogfight scenarios where altitude, power, and maneuverability dictate survival. Propulsion and adaptive cycle engine. The heart of the F-47 NGAD is its tri-stream adaptive cycle engine. Unlike conventional engines that must choose between high thrust or fuel-efficient modes, this engine automatically shifts between power profiles. During stealth infiltration, it reduces exhaust temperature and acoustic output. In pursuit mode, it channels airflow to increase thrust vectoring authority and compression efficiency. This versatile propulsion system supports near hypersonic dash speeds, letting the NGAD intercept distant threats or escape hostile missile envelopes before lock-on sequence is complete. Integrated cooling circuits allow the engine to power high-drain electronics such as the wideband radar matrix and onboard AI processors without performance loss. Sensor fusion and predictive perception. The 2026 NGAD defines a new era of information dominance. Its sensor suite includes quantum aperture radar arrays, long-range LiDAR mapping, electromagnetic sniffers, passive RF triangulation sensors, and thermal horizon scanners. Instead of feeding raw data to the pilot, the aircraft synthesizes all inputs into a unified tactical picture. The onboard predictive perception algorithm calculates enemy intent, likely flight paths, jamming strategies, and missile trajectories before they occur. This anticipatory capability allows the NGAD to adjust course, optimize weapon targeting, or launch countermeasures proactively. The aircraft behaves less like a traditional fighter and more like a cognitive combat organism, aware of its environment at all times. AI co-pilot in autonomous combat modes. Embedded within the NGAD is an AI co-pilot known as the Tactical Neural Core. This system manages threat tracking, weapon sequencing, emergency evasive maneuvers, and adaptive jamming profiles. In contested airspace, the AI can assume partial or full control if pilot workload exceeds safe thresholds. Autonomous combat modes enable the jet to conduct surveillance, electronic infiltration, and long-range strike missions without continual human supervision. These modes are particularly valuable in environments where communication blackouts occur, allowing the NGAD to operate with mission intent, even when cut off from command networks. Loyal Wingman integration. The F-47 NGAD functions as the command unit within a swarm network of loyal Wingman drones. These drones carry specialized modules including electronic warfare pods, air-to-air missile racks, ground strike payloads, and sensor arrays. The NGAD uses encrypted battlefield mesh networking to assign each drone real-time tasks such as flanking, decoy creation, radar disruption, and perimeter scanning. This force-multiplying capability lets a single NGAD conduct operations, traditionally requiring an entire squadron. Combined with AI-driven maneuvering, the drone formation acts as an adaptive combat organism, capable of encircling threats, overwhelming defenses, and preserving the pilot's safety. Weapon systems and hypersonic readiness. The 2026 NGAD houses a modular weapons bay designed to accommodate next-generation munitions. These include multi-mode air dominance missiles with variable seekers that switch between infrared, radar, and ultraviolet tracking depending on enemy countermeasures. Its long-range hypersonic strike missiles can penetrate hardened defenses at standoff distances. For close-range engagements, the aircraft carries micro-drone swarms that scramble enemy radar signatures by flooding them with false targets. Directed energy emitters mounted internally allow the NGAD to neutralize drones or disable incoming missiles without relying on kinetic interception. The weapon architecture ensures flexibility, whether operating in air superiority, suppression of enemy air defense, or deep strike missions. Survivability and electronic counter-infiltration. Survivability extends beyond armor and flares. The NGAD incorporates adaptive counter-infiltration protocols designed to deceive AI-controlled air defense systems. When targeted by smart missiles, the aircraft emits misleading telemetry packets that mimic its position, velocity, and heat signature, confusing enemy tracking algorithms. The onboard defense grid launches electromagnetic pulses that scramble incoming missile circuits without compromising the NGAD's internal electronics. Structural resilience is supported by nanoresin composites capable of distributing impact forces across the airframe, allowing the jet to return to base even after sustaining significant damage. Cockpit ergonomics and pilot integration. The cockpit emphasized seamless human-machine symbiosis. Augmented display contact lenses replace traditional HUDs, while neural gesture controls let pilots issue commands with micromovements. The oxygen regulation system monitors stress patterns, adjusting cabin pressure and temperature to maintain focus during high-G maneuvers. The pilot's body becomes an integrated extension of the aircraft's digital nervous system, enhancing situational awareness and reaction speed. Conclusion. The 2026 F-47 NGAD represents a transformative leap in aerial warfare. It is not merely a technological upgrade, but a complete redefinition of what an air dominance fighter can be: adaptive, predictive, autonomous, and resilient. With its combination of advanced stealth, cognitive sensing, AI-driven autonomy, and loyal wingman command capability, the NGAD stands as a symbol of future air power and the arrival of a new era where human skill meets machine-level intelligence to create the most formidable combat aircraft ever envisioned.